In this video, I will be talking about illustrating other types of sequences. So let me show you an example of a sequence. So we have this 2, 4, 6, 8, 10, 12, 14, 16, and so on. So it has a common difference of 2. That's 2 plus 2, 4, plus 2, 6, plus 2, 8, and so on. So that means the sequence is an arithmetic sequence. Now what if we're going to get the reciprocal of each term? So just like this. So reciprocal of 2 is 1/2. So reciprocal means you're going to invert the numerator and the denominator. But since the arithmetic sequence are all whole numbers, it means the denominator of each term is 1. So that's why if you flip it, it becomes 1/2. 4 becomes 1/4. 6 becomes 1/6. And so on up to 16 becomes 1/16. And this forms a new type of sequence, and this is what you call the harmonic sequence. So this harmonic sequence is a sequence where the reciprocal of every term forms an arithmetic sequence. So let's have another sequence. So we have this sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. So let's continue at the bottom. So let's copy the 34. And I intended to make it a failed 34 because it means it's the same as the 34 on top. So 55. So the continuation of 34 is 55, 89, 144, 233, 377, and 610. And so what's the pattern of this sequence and what do you call this sequence? So the pattern of this sequence is adding, to get the next number, we add two previous terms. So we start from 0 and 1. So this sequence always starts from 0 and 1. So 0 plus 1, then the third term will be 1. Then to get the fourth term, 1 plus 1, so that's the two previous terms, the 1 and 1, that makes it 2. To get the next term, which is 3, you add the previous two terms, 1 plus 2 is 3. And so on. So that's how we get the sequence. That's the pattern of the sequence, adding the two previous terms. But of course, the first and second term must be given, which is always 0 and 1. And then you do the next, you do the rule starting from the third term because it's adding the two previous terms. And this sequence is what you call Fibonacci sequence. And if you're going to divide this 1 by 0, of course you cannot divide it, so let's name it u, which means undefined, or you cannot divide it. If you divide this, 1 divided by 1 is 1, 2 divided by 1 is 2. So for now you cannot see a common ratio unlike the geometric sequence. 3 divided by 2 is 1.5. 5 divided by 3, 1.666, or round up 1.67. 8 divided by 5 is 1.6. 13 divided by 8 is 1.625. 21 divided by 13 is 1.615. 34 divided by 21 is 1.619. Of course, we are just rounding up to 3 decimal places because it's going to be very long. And then we'll divide 55 by 34. So we have the copy of 34 at the bottom. So 1.618 approximately. So we just round it up. 89 divided by 55, around approximately 1.618. So we keep on rounding up to 3 decimal places. 144 divided by 89 is 1.618. So observe that starting from 34 going up, we are already having a common ratio. Although the common ratio is not exact, but if you round up to 3 decimal places, it's gonna be the same. 233 divided by 144 is 1.618. 377 divided by 233 will be approximately 1.618. And also 610 divided by 377 is approximately 1.618. So that is uh, the quotients if you divide the terms with its previous term. And you will see that there is a common ratio starting from 34. And this ratio is special, and it is denoted by phi, capital Greek letter P, approximately 1.618. That is the ratio, and this ratio is what you call the golden ratio, and it is only uh, used for Fibonacci sequence. So let's have another sequence. We have this sequence 2, 5, 11, 20, 32, 47, 65, 86, and so on. So if we're going to subtract the terms so that we will know that this the type of sequence, we have 5 minus 2 is 3, 11 minus 5 is 6, 20 minus 11 is 9, 32 minus 20 is 12, 47 minus 32 is 15, 65 minus 47 is 18, 86 minus 65 is 21, and so on. So as you can see, there's no common difference. The difference of each is not the same. But then on the difference, if we're going to subtract the differences, so we have 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3, 18 minus 15 is 3, 21 minus 18 is 3, and so on. So as you can see, there is a common difference of the differences. And this sequence is what you call quadratic sequence. Another sequence. So we have this 2, 3, 7, 17, 36, 67, 113, 177, and so on. So what kind of sequence is this? So let us check. Let us subtract 3 minus 2. That's 1. 7 minus 3 is 4. 17 minus 7 is 10. 36 minus 17 is 19. 67 minus 36, 31. 113 minus 67, 46. 177 minus 113, 64. So obviously it is not an arithmetic sequence. There's no common difference. Now let us try to check if it's quadratic. Let's subtract the difference to get the common difference. 4 minus 1, that's 3. 10 minus 4 is 6. 19 minus 10, 9. 31 minus 19, 12. 46 minus 31, 15. 64 minus 46, 18. And so on. So there is there's no common difference on the differences. So it is not a quadratic sequence. Let us now try to get the difference of the differences. So 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12 is 3. 18 minus 15 is 3, and so on. So as you can see, there is a common difference on the second level, on the third level. So this is what you call an exponential sequence. Thanks for watching, and I hope you have learned from this video. Please support my channel by pressing the subscribe button, and also write the math topics you want to learn in the comment section.